Continuity of a function. When we talk about continuity of a function, we mean a specific point in the domain of the function. So say I have a graph of a function, and let's say this is some number 3, and when I say that at 3 this function is continuous, and let's say this is 5, and here the graph maybe jumps and goes like that. So let's give some numbers here. Let's say this is 2, let's say this y value is 3, and this y coordinate is 4. And this is the graph of f of x. So I can say that f of x, or f rather, is continuous at x equal to 3. And f of x is not continuous or discontinuous at x equal to 5. So a function is continuous or not continuous is only for specific points. So this function is continuous for a lot of points. It's only discontinuous at 1.5. Okay. Now, how do we make it mathematically precise? Notice why it's discontinuous at 5 is because the limit does not exist at 5. You can see that the left limit x approaches 5 minus f of x is 3, while x approaches 5 plus is 4. So the limit does not exist. Now, for a function to be continuous at some point, the limit should exist, and it needs something more as well. So let's draw one more graph where the limit exists, but the function is still not continuous because of that break. So let's say this is again maybe 4, and say this is 3, and this is the graph of f of x. So here the limit exists. Limit x approaches 4 f of x is actually equal to 3. But f of 4 is not defined. So this is undefined. There's a hole. At 4, so this function is defined for all values of x except 4. So that's why it's not continuous. Now, if I look at one other graph, so notice, and then maybe, so let me describe this graph to you. So say this is 7, and this y value maybe is 4, and this one may be 6. So what is happening here is the graph, as x increases, the graph goes like this, and then at one point it takes a jump, goes up higher, and right after that point it again comes back to its earlier location and goes. So here, and let's say this is again the graph of f of x. So limit x approaches 7 f of x. It exists, it is equal to 4, and f of 7 also exists. So f of 7 exists, and f of 7 happens to be equal to 6. So the limit is not equal to the value of the function. So this is not equal to f of 7. So that's why this is again discontinuous. So this is how you can test analytically. And in the graph, you can see that you can draw this graph without lifting the pencil. Now, what is the definition, mathematical definition for continuity? Now, if you notice, we defined in an earlier video that we say f has a limit. So we say f, now let me say, we say f is continuous at x is equal to a if for every epsilon greater than 0 there exists a delta greater than 0 such that we want to have this x absolute value of x minus a less than delta implies absolute of f of x minus f of a is less than epsilon. Now, when we define limit, we actually had 0 less than, because there we did not need this absolute value of x minus a to be 0, because there x need not be equal to a. But here we do require that x could also be equal to a. When x is equal to a, this inequality is still true, then it's actually 0 less than, of course, delta, because delta is a positive number. And what we want is absolute of f of x minus f of a to be less than epsilon. And so f of x will be equal to f of a in this case. So this is the definition of continuity of function at x equal to a. And we can list three conditions for f to be continuous at x equal to a. The first is the limit x approaches a, f of x should exist. Second condition, f of a is defined. And third condition is that the limit should be equal to the value of the function. So these are the three conditions that one would have to check to decide if a function is continuous. The function could be defined by a graph, in which case it's easy to tell. Here the limit exists, and actually let's go back to the first example we had. Here the limit does not exist, so the first condition itself is violated. Here limit exists, so first condition is good, but the function is not defined. So second condition does not exist. Here the limit exists, the function is defined. So first two conditions are good, but the third condition fails. Limit is not equal to the function. So we need all three conditions. All right, so that's continuity of function at x equal to a. And that's all I have in this video. I'll see you in the next one. Thank you.